Awesome. Welcome all. Thank you for joining us. We'll get started in just a minute or two here. We'll let a few more folks trickle in. Small group so far, but I'm sure folks will be a minute or two or 3, 4, or 5 minutes late, but no sweat.
Well, and if they like a lot, there's a recording.
That's always the benefit. Yeah. Here we go. A couple more folks. All right. Well, why don't we'll get started and just you can advance the slide, Jay.
Okay.
Thanks everyone for joining the Lunch and Learn today. We're all here for high performance as the baseline with Jay Gentry of Passive House, California. Today's sort of a less technical, more sort of soft skills focused webinar, kind of instructing on ways of framing maybe pitches or just ways to speak to your client when you're trying to process a sale or sell projects or elements of your project. So hoping we can aid that and answer any questions here on the call today. My name's Ian Logan. I'm with the County of Ventura and 3C Ren. I'm the program manager for our building performance training program. Again, welcome in, and I'll just have a few words before we get started. Next slide, please, Jay. So just a few words about Zoom orientation. I think we're all pretty comfortable here now at this point with 2.5 years of webinars, but just asking that everyone remain on mute throughout the duration of the training. If you do want to verbally participate, we can invite you to do so, or you're welcome to raise your hand in the participant section just to notify us whether or not you have a question. Otherwise, all questions and comments are totally welcome in the chat section. I will monitor the chat and relay any questions that come up to Jay. But if everybody would like to introduce yourself in the chat right now, that'd be awesome, just to get a feel for the folks in the room, and we can kind of tailor what's presented today based on that. Lastly, today's call is being recorded for our on-demand page. So if anyone wants to remain anonymous, just make sure you keep your camera off. I don't think that's really an issue unless you verbally participate, then you pop up, but just an FYI. And we will also be sharing the handout and slides and the recording of today after the class and some follow-up emails. So awesome. And just real quickly, you can go to the next one.
Somehow I wound up jumping forward too far. Sorry.
That's all right. You want to go to the one about 3C Run, the 3 counties?
Next one here?
Yeah, that one there. Awesome. So we're the Tri-County Regional Energy Network. We are a collaborative partnership between SLO, Santa Barbara, and Ventura counties meant to improve energy efficiency in the region. We offer free programs and services for building professionals and households. We are funded by ratepayer dollars that we all pay into in our utility bills through the public goods charge. And the benefit of being ratepayer funded is that there's no cost to those that we serve. And as a regional energy network, we're able to return these dollars back to our local economy that historically would have been distributed to the utility hubs. Next slide, please. So our three programs currently are Energy Code Connect, Building Performance Training, and Home Energy Savings. Our Energy Code Connect program focuses on industry trainings. We host regional forums, and we have a Title 24 consultation service called the Energy Code Coach, meant to help building professionals navigate California Energy Code and green building requirements. The phone number for our hotline is listed here on the slide. You can either call the number, or you can also submit an inquiry form on our website if you do have any Title 24 related questions, and they'll typically be answered within 24 hours. Another little shout out for anyone located in San Luis Obispo area. Tomorrow, actually, we are having our regional forum from 10 to 1 p.m. at the Monday Club in downtown San Luis Obispo. It's focused on IRA funding, Title 24, or the new energy code updates and how to make those things beneficial for the Tri-County region. You can find registration on our website as well, or even just walk in if you'd like. Today, we're all here for a building performance training workshop. We offer trainings on technical and soft skills related to building science principles and systems for high performance buildings. Our goal really is to bring industry recognized certification and training providers to the Central Coast that'll help advance people wherever they may be at in their career. And then lastly, our home energy savings program serves households that are historically underserved with free and discounted home energy upgrades through rebates and incentives. We have both a multifamily focused and a single family focused program for any multifamily property owners or contractors that work on single family homes. If you're interested in participating, please reach out, or you can also fill out an inquiry form on our website, 3cren.org. Thank you. That's my little blurb to start us off. So with that, I will hand it to you, Jay.
Thank you very much, and welcome everyone, and thank you for being here. This, as it says, high performance as the baseline, and as Ian mentioned, it would help you decide or sell or convince someone. If you're an architect or a builder and you'd like to build to a higher standard, you could. These would be some ideas that hopefully will be of value to you on that. The graphic that shows here is in terms of the baseline. That we really need is to have high energy efficiency, low embodied carbon, go all electric, clean energy. That's those are the steps to climate action. We'll talk about that a little more as we get further along, or as we go through. I'm wearing different glasses there, but I look about the same, I hope. I went to UCLA. I'm a Vietnam age person, so I picked flying instead of marching. And I've been a marketing and sales consultant pretty much my entire career once I got out of the Air Force. And I've been focused on the building performance industry, or the emerging industry it's now really rolling full tilt. For some years, I'm on the board of Passive House California, and I'm semi-retired, although hardly retired is the way my wife describes it. I spend most of my time advocating, doing this sort of thing for high performance design and building. The Passive House California, in case you don't know, it's an organization we are affiliated with the North American Passive House Network and Passive House Institute, or Passive House International. And our mission is to promote awareness, understanding, and application of the high passive house standards for envelope. We do it through events, education, things such as this, in an effort to really get everyone to know and move in this direction, which is an important part of going forward into the future. The graphic that I showed earlier is here, and this gives me a chance to say, you see this is a monthly epiphany. This is actually, it will be in a handout. It's a full page, a little over a page, and it describes this in a little more detail. The one point I'll make about it here is that while the implication is that the natural order is to make it efficient, minimize carbon, electrify everything, put clean energy on it and go to zero, and that's how you get to zero carbon. The reality is that while in terms of the actual implementation, they go in this direction, these are all decisions that should be made at the beginning of the process, that you want a building that is efficient, that is lowest and possible in the embodied carbon, that will be all electric from the get-go and will ultimately be getting clean energy. So this has some clicks to it, some other things, but this will be in your handout. I thought it was good to give you something that you can spend a little more time listening to me about it. The high performance as the baseline, I found it interesting when I looked up the word baseline and found that it means the minimum acceptable. I love that for Passive House. The logical starting point, that too. The standard to which we should be building things, the guideline, the norm, the best practice. That's what I mean by baseline. This Passive House represents a piece, not all, but it represents an important piece for the energy efficiency that contributes overall to the sustainability and environmental responsibility. So that's what we mean by baseline. And an example of that would be here, the baseline model. If you bought a new Toyota, or actually it looks like that might be a Chevy when I see it there, the baseline would normally be that would have all of these upgrades, or all of what that used to be upgrades. In the 50s, we didn't have safety belts or airbags or anti-lock brakes or the energy absorbing frame or the level of air tightness that we have in cars today. So if the baseline came without all of that, some people would choose to invest and others would not choose to invest more to get them. So because it's the right smart thing to do, the baseline model includes safety belts, airbags, energy absorbing frame, et cetera, and many more things. And the upgrades that you get are your sound system, your radio, leather upholstery, video, the things such as that. So that's what I mean by baseline, rather than the dressed up or fancied up model. The same thing should be true, ultimately will be true for buildings, that the baseline will bring in all of the positive things that make it the smart decision. Today, we're going to talk about, I'm going to set the context for just 4 or 5 minutes at the beginning, and then we're going to talk about how high performance has evolved, the evolution of high performance in buildings and what the parts and pieces of that represent. We will focus primarily on single family and other small buildings, but I do have some slides on multifamily, and I have some slides that are hidden if some of you are multifamily involved and would like to get a little deeper into some things in a climate, if time is available, we can do that. And then the final thing will be a call to action, which is simply, these are some things that you can do if you're interested and if what we've talked about today makes sense to you as a path going forward. The contextual element, high performance is the baseline. A high performance building is generally primarily airtight, thermal bridges removed, airtight including the windows and doors, sufficient strategic insulation that's there, and fresh air ventilation with heat recovery. Those are the things that go into it. And going again on into the contextual elements, that's the high performance as the baseline. The reality is that climate crisis is here. Greenhouse gases from human activities are a primary issue, and the embodied and operational carbon from the built environment are major contributors. We need to go forward, maximize efficiency, minimize carbon, and shift to renewables. And unprecedented action is what is required now and into the future. And you, by being here today, are a part of that unprecedented action, but we have a lot more to do. I show this slide just how logically and obvious it is that the track toward how quickly we are moving up and how it is accelerating. Obviously, it's clearly important that we do it. And the IPCC has called for unprecedented action. And a good comparative to that, in my mind, is in the year 1939, the entire United States military produced slightly less than 3,000 airplanes, military airplanes for military use. And by 1944, we were producing 3,000 airplanes every 11 days. So it is possible. And as we ramp up, we are ramping up dramatically at least primarily in the developed countries around the world, we're ramping up and headed in the right direction. And Passive House is clearly a part of that. the high performance is this is environmentally responsible, and we talked about this particular thing before. So when we talk in terms of the environmentally responsible, there are some categories associated with it that are energy efficiency, comfort, health. These from the inside, resiliency, durability, and ease of maintenance are pieces of it that are there. So for occupants, if you're just, if you could live or work in the building, if you're occupants and you pay your bills, the energy bills are minimized. It's much more comfortable, both emotionally and quiet. It's a comfortable place to be in a high performance building. You get fresh filtered air with minimized pollutants, allergens, and toxins, and resilient to heat, cold, fire, smoke, and power outages. It is a safer building to live in. So for occupants, it makes sense. For owners, there's the same operational expense, minimized, but the structures are more durable. The mechanical systems, because they're smaller and more right-sized, tend to last longer. The moisture management is very important and much easier when you have the air tightness associated with high performance. And your maintenance expenses are generally reduced, and it's increased fire resistance. So a lot of good things about high performance if you're the owner of the high performance building. And if you are here, click it here. Or my computer is struggling with going. I don't know if you can see the little spinning rainbow. I'm not sure what happened. There we go. For communities, high performance building communities, and there's a community in Colorado that's building back all to passive house because the houses not only all burned in a wildfire the last year, the burning transferred from home to home to home in a way that they'd like to get them all so they're more resilient, because if you don't catch one on fire, it's hard to catch the rest of them on fire. So the resistance to that and the smoke is good, and the resistance to the smoke is good. And when you have communities, and this includes campus communities for universities, or business communities for large corporations or companies that have things, or gated communities, the possibility of building or creating a microgrid so that you're resilient to power outages is dramatically increased. It's much easier to do if the buildings are high performance, because they're burning or using half of the energy, let's say, that they would be if they weren't. And as a result, you have a much smaller amount of energy that you have to recover in order or keep when you have the power outages. And ultimately, high performance buildings are part of fighting climate change because of the reduction in greenhouse gases and the easier path to where we need to get to, which is the zero net energy and zero net carbon. We'll now step into the evolution of high performance buildings, how we came around and stepped into this, into where we're going. It started a long time ago by making intelligent and smart choices when you decided where you live, and it continues on now as we go on to here. Looking at that, at the cave dwellers. If you look at this, and if you go worldwide, not all certainly, because they are what they are, but where they've hollowed them out themselves like this and done things to do it, what they look for was in the northern hemisphere, you find a high percentage of them are south facing because the winter sun is low in the sky and comes in and helps warm them during the cold time, and the summer sun is higher in the sky, so doesn't get in as much and doesn't overheat them as much in the winter. In addition, they choose locations that provide access to water, comfort, safety, visibility, light that's there. And I might point out that that a lot of the things here are passive, because once they hollowed out the place that they're going to live, they can pull up the ladder, and it's always safer and more difficult to attack. They can see that you can see others coming if they need to. So we've been making these intelligent and purposeful choices for a long time, and it was about conserving human energy, staying close to water and those kinds of things. It was really about survival at that time. Over time, we have switched from human energy to energy from fossil fuels and electricity, which is largely produced still by burning fossil fuels. And because of that, we now know that we need to do other things. We need to decarbonize the built environment by maximizing efficiency, minimizing embodied carbon, electrifying everything, and shifting renewable energy. And we need to do it because survival is back on the table. So this is really critical, which was the first of the contextual things that I wanted to, or not the first, it's one of the contextual things that I wanted to bring up. In terms of why we haven't done more, or what could be, where we could be had we done more, you can look this up on YouTube and just look up 2009 Chevy Malibu test dummy crash, or test crash against a 59 Bel Air. It's a very interesting video because as you know, the Bel Air, the 59 car, is much heavier. It is somewhat longer, but it doesn't have all of the improvements that have been made up to 2009. So what you wind up with, as you see the details of it, is the car built in 1959 code, as I said, is longer and heavier, but the code now, the new baseline for code as it came up, is all of these safety features. And what the result is that that the driver of the 59 car incurs multiple catastrophic injuries in the way that it collapses. But because of the airbag, the seat belts, the collapsible frame, and the things associated with the newer car, the driver walks away or maybe limps away. There might have been some damage to the feet, or to one or more of the feet that is there. Interestingly, the reason that, or not the reason, but a key driver of that happening with 50 years to make the cars better, the driver of that in many ways was the insurance industry, because it was, you know, they wanted to have lower payouts, fewer fatalities, things to go operate. So they insisted on clarity of the performance related to goals and objectives for safety, as it was there. They applied analysis and incorporated science to achieve performance and different safety things. They integrated innovative solutions, and then made all of the auto companies commit to delivering the expected results. There's no reason that we couldn't do that in the building industry, or in the home, you know, the development construction industry, as we add the goals of high efficiency, low embodied carbon, the goals and the things. We know how to achieve them. It isn't that we don't know how, we do know how, but we didn't have Ralph Nader and the unsafe at any speed to set the stage for the insurance industry to drive and make them happen. We are starting to make them happen, or more than starting, we are moving forward on making them happen worldwide, because it's the smart thing to do. Setting the right goals, and the right goals are, as we've discussed on others. So it's not driven by regulation yet, but we're getting closer to having it driven by regulation. In fact, in terms of the evolution, in the 60s, we had the Environmental Defense Fund and Greenpeace, and we were becoming aware that mankind was driving changes, and unhealthy and unsafe changes across the planet. But we were thinking it and doing a little bit of action. Then we came up with ways to set prescriptive standards to choose it, as we say here, LEED, Energy Star, Build It Green, and Green Point Rating. Those are all prescriptive standards where you do things, you use Energy Star this and Energy Star that, and make smart choices as you go forward to be more, to have an opportunity to be more efficient and sustainable. The next step was to measure it. So we got performance standards and performance certifications, which includes Passive House, Living Building, Well and Reset. Those all, you don't just order to start out there. You measure it and confirm that you did get the performance that you were looking for and expecting. And now, just recently in New York, it became, you have to prove it. I don't know if you're aware, but in New York, starting in 1995, even existing buildings, and these are for large buildings, but all existing buildings, they will be provided with a budget for the amount of energy that they can use to heat and cool the building and in the building overall. And if they don't get to that level of energy use, there are fines associated with it that will increase every 5 years going forward. So they're actually making companies prove it on a year-to-year basis, and the target is high performance, and it is the things that we have talked about. So from a contextual standpoint, we are past the threshold and moving into the time when we can drive it and really get the unprecedented level of action that is necessary. Passive House, as I said, is a piece of that. I want to take a little bit of time to share with you, for those of you who don't know, just some of the basic concepts of Passive House and how it works. Passive House is, in fact, the world's most aggressive energy efficiency standard for buildings. And it's been a few years ago, in 2017, the United Nations endorsed or recognized Passive House as a global standard and a model for construction and existing buildings in the developing world and in the developed world. This was published in the ECHO report in 2017. So Passive House is recognized as a piece of the puzzle. Because it's called Passive House, people think of it as a single family home. Actually, some people think of it as a yurt with a window because of the pictures of passive houses in really cold climates. You wind up with generally less glass and things. We now, from a building science standpoint, know how to build to pretty much any style in any climate zone. Certainly in the climate zones we have here in California, you can easily build a passive house to be, to kind of look like any style that you're looking for. And it's not just houses. The word in Germany for house, or HAUS, can apply to buildings as well. So this is in Palo Alto. This is an architecture and construction office. Two different companies decided to build it as an example, and they build passive homes for their customers. There are many, many multifamily passive house buildings around, and more happening. I believe that we are just a few years away from having this become just the standard to build a passive house because of the benefits that you get from it. And even this is in New York. This is a passive house building or passive house block that is under, it is under construction. And it's going to, when it's completed, it'll have 750,000 square feet of mixed use, 655 affordable units, commercial space, school. And the big picture is this entire city block will operate on less than half of the energy that it would have if it had been built to code. So this is one of the reasons that New York is out in the lead. Another reason that New York is out in the lead is because so many people live there without cars, and they live so close and travel and move around through public transportation, that whereas in California, the built environment is responsible for around 40% of our energy, of our greenhouse gases. In New York City, it's closer to 70%. So it's a bigger deal for them moving forward. And this, by the way, just so that's not a picture, not just a picture of what it's going to be like, it is underway. This is from a few months ago. In New York, those buildings are on the way up. So passive, a part of one of the keys to understand passive houses, it's passive. I mentioned earlier that when the cave dwellers built their caves facing the direction that they were and up in the air so that you had to come up a ladder to get to them, those were all passive solutions. They built it that way to achieve certain objectives that are automatically achieved as they go through. So the natural order of sustainability is to do all things that you can that are passive, that don't have to be repeated, don't have to add power, don't have to update, upgrade, and things like that. They just simply perform the way that you want them to perform. So you want to do passive things first. Because of the airtightness and the efficiency and things associated with it, the active systems tend to be dramatically smaller. And then you go to renewables third. Many of the solar companies out there, most in fact, will look at your energy bill and just suggest enough solar to offset it. Whereas the smarter thing to do, particularly for larger buildings, would be to look at what you can do to reduce the energy use and do that first. And then when the renewables come, you still get to zero, but with a lot less renewables, and it's a better overall solution. I mentioned it with respect to the caves. This is a more specific example of the summer sun not getting to the window because the eave, which was a passive solution, it blocks the hot summer sun and allows the winter sun in when it's cooler, and the winter sun and the solar heat gain from the winter sun coming in can be brought into a thermal mass if you want to, and the house will have it will stay warmer during the cold day and start from a warmer temperature during the cold night. So it's a smart thing, and it's a passive solution because once you design it and put it together that way, you are there and you've got it. The passive solutions deliver it naturally as a function and continue to do whatever it is you want to do. I use two examples to talk about that. One is the race car. The wing on the race car performs like an airplane wing upside down. So it actually, instead of lifting the airplane off of the ground, it presses the back, and there's a little wing here in front as well. It presses the car down at speed. So the car it feels like it's heavier, but it's hard. There's more pressing down so that when you turn, it has much better traction. But you could get the same amount of better traction by putting weights in the car. But then when you try to turn it, the centrifugal force would push them off would tend it to pull it offline. So this is it's an elegant passive solution that makes race cars corner faster and more safely. And it works as long as a race car is operating. You don't have to do anything to it other than put it there in the beginning and put it there correctly. The second one that I like to talk about is reverse diagonal parking, and some of you have probably seen that. It is becoming more common in parks and sometimes city downtown areas and things. And the goal, in the same way that the cars being safer, the goal here was to make it safer for the passengers when they get out of the car, because when you pull the car in a forward diagonal, and it's a park, the bike rack and the bike rack is on the back of the car. The picnic basket is in the trunk. The doors cause the kids to get out and go to the back of the car, and so there are individuals and car accidents and collisions that happen that are largely eliminated by doing this. And so again, it's a passive solution. As long as the lines are painted in that direction and you're required to park that way, you have fewer accidents that involve actually people being bumped or hit by cars. Another thing that I like to point out here is it didn't cost any more to paint the lines in this direction. And there are many, many things associated with building to a really high standard that don't necessarily cost more or be more difficult once you know how to do them. They can be done with little or no additional or changed investment. So as I said before, the passive first, and the passive gets bigger, the active gets second, and then the renewables come third. So how does Passive House deliver performance? What does it do? And by the way, you can note here, the Passive House in this picture is this one. And what you see, this is a thermal photograph, and the heat from inside the building is transmitting or transferring through the walls. The walls are hot and warmer on this building. And on this building, they're not having to add that heat over and over again because it's not escaping at nearly the same rate. So it is a smart way to go. So how does Passive House deliver performance? It's not unlike the way you get performance if you happen to be a fireman or firewoman running into a fire. In order to protect you from the hostile outdoor or outside exterior environment, what you do is you have something that you can wear, personal protective equipment. The same thing would be true for an astronaut, although it's not the hot that's dangerous, it's the cold that's dangerous and the lack of oxygen. So what you get for those in both cases is an airtight shell or envelope, a sufficient insulation to avoid the intrusion of heat from the outside or loss from the inside. So you can see that both of these are insulated outfits, as you will. You could make it airtight with saran wrap, but it wouldn't be much help in a fire or in outer space. And then the third thing, of course, is the continuous fresh air. It's not a wives' tale, but there's an old thing that buildings need to breathe. And that is true in terms of allowing the moisture to escape so that you don't wind up with deterioration on the inside. But they don't need to breathe air, but the people inside do need to breathe air. So the continuous fresh air, and in the case of a passive house with heat recovery, which we'll speak about in a minute, is the smart way to operate. So this personal protective envelope for the people is a personal protective envelope for the it's personal protective equipment for the people. It's a personal protective envelope for the people inside of a passive house building. The basics, the three key elements are: you need to figure out where your air barrier is and create an airtight building shell, including the windows and the doors that are in that envelope, that are part of that envelope, need to be airtight. The second thing that you want to do then is get better insulation correctly applied so that you have a strategic and climate specific amounts of insulation going in. Correctly applied includes elimination of the thermal bridges that can be there. You don't want the heat bridging out or out from the heat that you've provided on the inside to the outside in that picture that we saw a few slides ago. But you also don't want the heat from the outside coming in. And so you need insulation, and you don't want the thermal bridges that are there. As an example of thermal bridges, I beg your pardon, here are the two, this is another passive versus active example where you can have your hot coffee all morning and again all afternoon. You can do it with the thermos, or you can do it with this. And with the coffee pot, you wind up, you've all been there when the coffee all burned out and you wind up with it, fixing it because you smell it coming from the kitchen room. To do the things to the envelope, it's not magic or anything dramatically different from what we do with regular buildings. It is simply just a bunch of the details that you operate with for the places where it's hard to air seal, the corners that are there, around the windows, at the base of the building going through. The details associated with the ceiling and the insulation are important, and you want to get it all the way across. You do the specs as you're going, and and you have to communicate how to do this and go forward with the contractors and all, and everybody that is there to do it. But it is not dramatically different. It is very much like the car in just getting the airbag, the seat belts, the things. Didn't change the appearance or performance of the car. They were simply around doing the right things. With regard to a thermal bridge, if it's not familiar to you, this one would be, in that we all know not to pick up an iron frying pan that we just cook something in without putting a hot pad on the handle, because the handle gets just as hot as the rest of it, because the heat bridges up through the iron and out into the handle. That is the case with buildings as well. And you can see here the heat bridging out against the top cap around the tops of the windows in particular. You can actually see the heat being generated, bleeding or thermally bridging through the studs. And clearly underneath the house, they've got some heat issues, probably some leaking furnace, some leaking ducting, or something that's making it pretty hot underneath the house. So the bricks on the outside, or the stone on the outside, they're creating a lot of heat energy that's being washed through, that's being transferred. So they have to keep doing it over and over again. And for a bigger building, you can do things like really make the insulation right so the building itself stays black and stays really, really cold in a thermal photograph. But if you don't realize that when you put a deck on, you've got to break the thermal bridge between the cement or the metal or the things that are supporting the deck, or you wind up creating something like this, which is sort of like a radiator for the neighborhood. So the second of the two big steps is strategic insulation correctly applied. And that's without thermal bridging. So you need to eliminate the thermal bridging. And the passive house planning package is one of the few places where you get that opportunity to do it. The third step, because people need to breathe, you need fresh air inside the building. So you get mechanical ventilation with heat recovery. And generally you take the warm air inside out of the wet rooms, like the kitchen, the bathrooms, the laundry room. It passes through a heat exchanger. So this hot air passes through the heat exchanger while the cold air from outside passes through the same exchanger. They don't mix. the air doesn't mix. So the moist, polluted air that's going out, that air goes out, but the heat from that air transfers to the air that is coming in. And that's called a heat recovery or energy recovery ventilation system is what does that. And as you look at it here, the extract air from the stale air rooms that's going out exhausts, the air from outside comes in, and it comes in. And to get an idea of it, if you have a 90% efficient heat or energy recovery ventilation system, the 70-degree air, and it's 70 degrees inside, the 30 degrees outside, that 30-degree air, when it comes in, is warmed all the way up to about 66 degrees. So you're really only having to deal with a few degrees of a little bit of air that is providing, however, continuous fresh air to the inside of the home. And the air that's going out, of course, the temperature drops down in the air that's going out. And I have two other things here. Because it's coming in, once you have an airtight building, you can control the air quality. You have complete control of it. So you can filter it to whatever level you want to. And something that's happening now quite a bit across the West is you're having a basic filtration system which works for regular times, and if there's smoke from wildfires or something else that really that you need to get out of the filtration, you can shift over to and have the air coming in filtered through a HEPA filter and getting not all but but by far most of the smoke out. And so you think, well, this is not passive, this is active, it's going to take energy to run it, and that's absolutely true. But because you're transferring a small amount of air at a slow speed, just to get to continuous fresh air inside, that air, it's not moving fast. And in fact, for let's say a 1,600 square foot home, the energy required is equivalent to about a 40 to 60 watt light bulb. So it's very, very low powering of the fan, and the transfer of the heat is taking place in a passive system that is structured so that the way the air passes through the tubing or the plates or the ways that you're getting it out, that the heat transfers without the air itself mixing as it goes through and transfers. The 5 key principles, I mentioned the 3 things, the airtight, insulation, heat recovery, ventilation. Just so you know, I used a small house as an example, but here's a 4-story building. And again, you've got the airtightness with the high performance windows and doors for continued air tightness. You've got the climate specific insulation with the elimination of thermal bridges, and you have the high efficiency heat recovery ventilation. So you can do it in buildings of any size. It's the same 3 main things or 5 key principles that they set up. A way of thinking of it is to think of it as the building blocks to get to high performance. The building blocks are the airtight envelope, the climate specific insulation, the balanced ventilation, which is much healthier with heat recovery, and then you can add renewables, and it will take a smaller amount of renewables to get you to the goal that you have of minimize. The initial focus of energy is on the envelope, and this is kind of a repeat of what I just said on my own, is that it gives you control of air quality, so you can do that, and it also provides resilience to heat, cold, and fires and smoke from fires and things such as that, and power, including power outages. So it's when you focus on the energy efficiency, you get a great start, and there's many other things you can do to make it more sustainable and going through. A passive house will have about an 80 to 90% reduction in energy required for heating and cooling, which is a similar drop, by the way, the drop you get between an incandescent light bulb and an LED light bulb. So we know how dramatic it is. About a 70% reduction in total energy use. And that's in California, that is today, because our codes are higher than in general, that's more like 50%, but still it's very significant. It enhances and accelerates the impact of renewables and storage. You can have your same battery pack that you have will operate the house for twice as long, or if in the case of here, over 2/3 as long. And you need smaller renewable arrays and things such as that. A big one that is a high motivator is the 95% reduction in unwanted infiltration of the airborne pollutants and allergens. Because air is not leaking in much at all, you have dramatically driven down the allergens and the things floating. In fact, if you've ever been in a passive house or have a chance to get into one, find a window where the sunbeams are coming through and see if you can find any dust motes floating around in them, because there are very few. If you don't have pets, you can go a long time between dusting, but between opportunities to dust. And you've got the comfort, the healthy indoor air quality, durability, resilience, and et cetera. So those are all of the things that are there that you have it. And by the way, if it's not hot, cold, windy, polleny, smoky, noisy, if none of those things are going on, and the weather is fine, it is particularly fine. It's fine to have all the windows and to have windows open and have fresh air in a passive house. You don't have to keep it sealed up all the time. Just when you have, as I said, hot, cold, windy, pollen, all of the things that you're trying to avoid. And as it turns out, in general, people who own passive houses wind up not opening the windows much, simply because you would typically open windows because it's stuffy inside, or because you have a reason to open the windows. And it's always 70 degrees upstairs, downstairs, no drafts, that sort of thing inside a house that's built to these kinds of standards. We mentioned resilience. Resilience is really important now because of the heat and cold, because of climate change, the wildfires that are caused, the smoke from those fires and other air pollutants and power outages. Just so that you know, the robust thermal enclosure, or the envelope, is what does extreme heat and cold. Fire hardened for the enclosure is for wildfires. The airtight enclosure with the fresh filtered ventilation system, and the robust thermal enclosure for energy storage. A high performance enclosure is the #1 priority for achieving resilience, and air sealing, making it airtight, is the #1 priority for allowing or for causing that to happen as you go. So that takes us through the evolution of high performance and how we got there. We've been talking about single and multifamily to now. Let's turn our attention to single family buildings for a few slides to get to where we need to go with it. We've seen individual small buildings and things that are there, and we know that we can go to larger buildings as we do. We tend to, the way we have built houses in the past, or those kind of buildings, is we treat it as kind of a relay race, where all of the people, the owners who are going to live in the home, let's call it, they know how many bedrooms they want and how many bathrooms and what it should be laid out like, and room for the pool table and the things like that. They have their preferences and realities that they're interested in. And by realities, I mean what their budgets are and what they can let happen. And the next step then is to get somebody to help them with the design. They'll find an architect who will listen to their needs and will help them go through and will design a building that actually meets the needs and heads in the direction of what they're looking for. And then they will put the bid out to multiple builders, so that you get a builder who translates this vision of what it's going to be based on the planning documents and things, to interpret the plans and handle surprises going forward, and to get it to execute. What we now know, though, and we know by proven, and we're shifting more and more toward it, is instead of going with the relay race, treating it as a team effort. Because if the client and the architect and the builder meet together, and you can have multiple builders come in one at a time to learn about it, if you want to select which build, if you like the idea of being able to pick among 3 builders that come recommended, that's fine. But selecting the builder during this process is much better, because when everyone is aligned, this vision of what the house is going to be and how to get there is achieved much faster and much more completely. You wind up with getting the house you were looking for what you could afford to spend, because a lot of times an architect will design something that is beautiful and appropriate and very nice, but without the knowledge of the contractor of costs back and forth, of the cost to do this versus that, it's difficult to maintain it at a budget level that you're looking for. The biggest surprise working with it in this process is, and has been for years, the cost differential between what you were hoping for and what the reality is coming through. It's just a smarter way to do it. So collaborative team leaning into high performance is a better way to design and build, and you wind up getting the high performance when you do it that way. We talked about part of the baseline is you site the building and shade it in ways so you take advantage of the winter sun and the warmth from it, but you don't get the disadvantage of the summer sun and the heat that comes from it. So siting and shading is one of the things that you can think about. Part of the baseline is also the actual shape. If you design a building if a simple building and minimize the surface area, corners, and perimeters, it makes it much less expensive and much easier to build. For example, this one in this building, we have 4 corners, and we'll call it 100% of the surface and 100% of the parameters. The surface, the amount of surface area, if you have more surface area, you need insulation on more surface area, and sometimes increased insulation because you've got more opportunity for the heat to transfer out or the heat to transfer in as it goes through. If you take that same building and you just put one little corner out in it here, you wind up with 8 corners. You double the number of corners you have to deal with. You added about 10% to the to what you need in terms of the area you need to insulate, and the perimeter is necessary to go around the perimeter. Again, the perimeter is the whole area that needs to be air sealed at all the corners and things going through. And if you take an even more complicated look, you wind up with 3 times the number of corners you've got to keep sealed, 120% of the surface you have to make airtight, and 130% of the perimeter, plus extra insulation, because you've got more places more ways for the heat to leak out through transfer. A builder that I work with likes to say it's easier to keep an elephant warm than a snake because of the surface area. Another part of the baseline is your thinking of windows. You want to make smart window choices as opposed to making windows part of the decorative parts. Not that they aren't a part of the decorative part, that's just not how to start with it. Windows should be, you want windows so that you can get daylighting and have better lighting without having to turn lights on all the time during the day. You can get fresh air when you want it. You get the views that you're interested in. You have egress, which is a rule of going up steps and around certain places, and air tightness. The windows that are here are double hung, and they're beautiful in this bay orientation that they have, but it's much more difficult to get airtight in a double hung window like this. The tilt and turn windows are where we're generally headed with respect to passive house or high performance. A couple of other things. Another part of the baseline is things that are available. For example, prefab construction is available, where they can build the walls, the ceiling, and the floor to the air tightness standards and the insulation standards that you're looking for, and they will have there'll be raceways inside along the inside of these walls, so that you can run your electricity and your plumbing without having to penetrate the envelope and risk the leaks that are there. So that's something. Another one is the cross-laminated timber. Because cross-laminated timber is a wood product, wood sequesters, or trees sequester carbon. You're now taking carbon that, when the tree is cut down, that would either, if you let it rot or burn it in some way, you wind up giving up that sequestered carbon in addition to the smoke if you're burning. But with the way that when we're looking at it here, this is actually a carbon negative approach to embodied carbon, because you have embodied carbon that you're saving as you go through it. And both of these, by the way, are passive solutions, because once you build it that way, it stays that way and performs that way. So thinking in terms now of the baseline and the idea, we typically think in terms of high performance as an upgrade. You have a code compliant building, which is a nice building. In California, it's nicer than other places. You can't see any changes. And if you want it to high perform, if you want it airtight and with better insulation and the heat recovery and the things like that, you might have to spend a little bit more. In fact, we are in the position then of saying that the choices you make essentially lead to paying a premium. But if you take the approach from the 2 cars that we saw earlier and say that we're going to make the baseline the state-of-the-art performance, the state of the science performance, build it as efficiently or so that it is as efficient, comfortable, healthy, durable as possible, then you might, if you don't want to do that, there are some things we only have to get to pass fail minimum standards. Code is essentially the elimination of defects. Quality is more than the elimination of defects, but you could go down, reduce performance, but you get to be in the position of asking your client or the person you're talking with, you can choose to reduce costs, but you're going to have to give something up. Which would you like to give up? Energy efficiency, air quality, comfort, resilience, resale value, peace of mind, durability. And people love to win, but they hate to lose and give up. So as we begin talking about and believing and designing buildings to the high performance level, most people will stay with that because they don't want to give up anything. So that is the main thing of the workshop here, or the webinar that we're doing. And I've included in the handout another epiphany that kind of makes that case so that you'll have an easier way of making it yourself if you want to later. As we move to large buildings, multifamily buildings, and other large buildings, we will, with some things we can talk about here. The passive house is scalable. You can have it as an ADU. It can be a small building. It can be this building that we've talked about here, or all the way to this city block. When you build something and you're trying to, if to take the analogous that the egg is what we're protecting from heat, from too much heat, too much cold, bad things happening to it, you can enclose it, and that's, and it's an enclosure, and it's going to cost a little bit to do it. And if you have a dozen of them, it's going to cost a little bit on each of a dozen of them. But if you put them in a multifamily context, you can achieve the same things. The airtight portion of it and the insulated portion of it is only necessary around the outside envelope. So it's possible to build passive houses passive house multifamily buildings that do not have to cost more. These are 3 actual passive house certified multifamily buildings that are there. They're code compliant and airtightness. If you take code compliance versus passive house in this going, and when I say passive house, I could just as easily say extremely efficient, because passive house is all about the efficiency. It's achieved with the envelope and the fresh air, the handling of the air, but it is all about efficiency. So the reduced operational energy is up 70%, as I said before, about 50% in California. You reduce unwanted airborne pollutants by the dramatic amount that we talked about. And you might expect as much as a 5% more or less. Here is a study that was done in Pennsylvania. The Pennsylvania Housing Finance Agency back in 2013 said, hey, we'll give you 10 extra points on your RFP or on your response to the RFP if you'll say you'll pursue passive house. And so they started out with houses doing, they now have 194 conventional and 74 passive house. And over the years, they've been building them. And what they found was that the first year, the 2 blue ones here, it was about a 6%, 5.8% more expensive, because the contractors and the builders didn't know exactly what to do. It was a first time through for them. The second time they built buildings, it was about 1.6%, about 1.5% more, because they learned a lot of things. And ultimately, by the third and beyond the third, it's less expensive to build a passive house building. And that's not all about performance. That's part of it for the architects, because they understand the simplicity and the advantages of fewer corners and decorating. Well, in fact, here it's the next slide, I think. The idea of, we want to do that for the people on the planet. The question isn't why would you build high efficiency? The question is why not? Then we talked about this. The architects have learned about the simplicity, and they tend to build buildings that are supposed to be super energy efficient with more efficiently. They know about the windows, and instead of decorating with the envelope, they decorate instead of decorating using the envelope, they could take the envelope and decorate the envelope. And they have the same things for windows in terms of why the windows would be there. So imagine wrapping a package. A box like this is pretty easy to wrap and make it look really nice. You can even get fancy with it and make it look terrific. You could do really special things But if instead of building it as a six-sided thing with a lot of instead of decorating it after you build it in terms of the concept, it's much more difficult to get the tight fit, the air tightness, and all of those things associated with it. So we don't want to do that. It costs you money to do it. The new baseline in multifamily buildings is what I would call, or I call it, evidence-based performance, is knowing before you start what you're going to get. The greatest trend, this is from a group that does this kind of work, they're like, that they are seeing and they're constructing and doing things, is they want to know how it's going to perform before they spend the money to build it. It's not good enough to design for it. They're demanding proof of performance and operations as it goes through. So I've got you, there's an epiphany for this as well to talk about. You've got to start your planning early, build it around the envelope first, and then aspirational goals. Do it to a high level if you can, because if you plan it to a high level and have to back down, you wind up with a much better overall than if you just build up to what you think you can afford. So you set performance goals and measurement methods, employ detailed modeling early, test and commission as you can going forward, and then monitor the performance to get the evidence and the performance that you want. If you're not familiar with it, and there's a link to it in actually in one of the epiphanies that's there, Patrick McLeamy was with HOK Architecture, and he came up with the idea that traditionally the big spending in terms of the design and getting getting the things from the MEP, the engineers and the things through it, the hump and where you spend the money is out here. But if you moved that hump to, if you move all of these things over here to where the green is, it doesn't change the total cost at all. It simply gives you a much higher ability to control that cost and to make design changes to get it right early in the process. So what you're looking to do is to begin with the end in mind by knowing what you want the performance to be and how you're going to monitor and measure that performance. Then you detail the modeling and do the budgeting so that you can make early decisions at a high control, low cost point. And you can also inform value engineerings along the way. When people say, yeah, we could change it and save this much money, you can look at what it would save, but also what it's going to cost in terms of performance and month to month going on. And this is also true for remodels, in that for a renovation project, if you start with what is possible and adjust down to the realities of time and budget, you achieve a better outcome with a reduced risk and fewer surprises. So getting all this figured out in the beginning is a key step to where we're trying to go. To get this in the single family, I mentioned the vision you saw come together. Within a multifamily, you want the architect, designer, the major consultants and subs, and the contractor all a part of the integrated team that figures out how the building should perform. And then you work toward that. And as you, again, if reality causes you to back down, you still get to a much higher level of performance. And you get this evidence-based performance, this dotted line being the modeled performance of the building for 3 years, and the bars being the actual performance. So that's where you want to go if you possibly can. And I've been pitching Passive House, but I haven't been pitching Passive House as an alternative to LEED or living building or different things that you do. I'm talking about it as an addition, as an integration with it, because it works synergistically. The Passive House works synergistically with the other standards because it's more stringent and sets the bar higher in terms of energy efficiency, healthy indoor air quality, and resilience. You get a much better result without changing any of the things that you do, other than focusing on the envelope early and getting the high performance there. I use an analogy to talk about this. Imagine if you were putting together a football team, you would want to find the best players that you could in every position. You would know the parameters around how much they ought to be able to bench press and how fast they are and how well they catch in those things, depending on whatever position they were in. That's very similar to a design build team using LEED and Cal Green, for example, that is the highest, that's the most frequently used with multifamily buildings here in California. These are point accumulation things that reflect required desirable levels in lots of different categories. So the different categories here in terms of water or toxicity or all of those things, which are all important, are very much like the high performing players in a football game or on a football team. But having all the good players aren't going to win very many games unless they have a playbook that integrates what each player does on all the different plays. They have to work together as a team in order to have the plays work and function. And in fact, not just work together as a team with the playbook, they will have a game plan to play offense or defense against a specific opponent to get their desirable outcome. And the corollary to that from a design build team standpoint is to bring Passive House into the picture, because the Passive House planning package integrates all of the elements into a predictive model that forecasts the specific performance that you'll get. And also the game plan, because it allows you to make informed choices to achieve your goals at a cost-effective way in the performance of any specific building. So it's the next step in getting smarter as we head in that direction. High performance as the baseline is where we started. Now the call to action, things that I would ask that you consider, or that I would raise as possibilities for you to consider as you trundle off into the future to help us get to where we need to get to. The call to action, I would say, we have learned from studying it that if we look at Vancouver and New York and several cities and areas of Europe, we've learned to identify who the leaders are, set higher targets, support the front runners, educate everyone, remove barriers, and increase incentives. The ones that all of us can be involved in is to educate everyone and to prove it, show the pilot project. Once you show it and it works, everybody wants to do it. So for you, if you know of any organizations or groups that might benefit from learning more about building blocks of high performance, and you need a presentation, reach out to info@passivehousecal.org, and I or somebody would be happy to make a presentation, tailor it to the specific architectural firm or solar firm or whatever it is. But getting everybody educated about what is possible is an important first step. In terms of pilot projects, if you're aware of or have ideas for buildings, pilot projects, things that could happen or are currently on the horizon, again, reach out to us, because we would love to be in touch with and help whoever's trying to do that get it so that it works in the way we want it to work, or the way that they want it to work. You do the planning and the charrette in the beginning with the integrated team to see what you're trying to get, and then you go through the process of getting it. And once you've been in a passive house or a really high performing building, you'll know it. You can feel the comfort, and you have the comfort associated with you're doing the right thing for your family and the people that are living in there with you. Some personal opportunities. You can take passive house training. There's a tradesperson training. There are basic trainings. There is the certified passive house designer consultant training. And you can get that by going to NAPHN or naphnetwork.org. They have the calendar of all of those that are going. But thank you, 3C RIN. 3C RIN is running those trainings, not week after week after week, but periodically running those trainings for free and getting people certified, which is a very important thing. PG&E is also is getting ready to do that for those of us who are in Northern California, or well in the PG area. You could join Passive House. You could just start going to the website and looking at what you can learn. But you could join. We are strictly a nonprofit, strictly based. Our revenue is memberships and sponsorships and donorships. You can join as a company. If your company does this kind of work, it might be good to join, because we have a project listing and a company listing that would allow you to get to people to find you when they're looking for that kind of help. You could sponsor. We would love to do that. We do workshops and things. You could sponsor that come through, donor or volunteer. PassiveHouseCal.org is where you can find that information should you choose to do that. So that brings us here to the end. I like to point out this light bulb. This is you in the room here, or you that are with us. This is the only light in this entire image that is lit, but the light from here is spreading around to the ones to the others that are there. Let me put up, this again is my name, my email, and my telephone number. And on a time available basis, as I said, I'm hardly semi or hardly retired. This is my passion. I have children and grandchildren, and I am willing to help as much in any way that I can to get us to where we need to be. So I've given you hopefully enough time to read these. What I will do is I will unshare, and we'll be back to looking at each other. And we've got about 15 minutes or actually 20 minutes for question and answers. And I do have some slides that I didn't show that we could potentially go back to if we had questions that needed to be answered in that way. So do we have any questions in the chat?
No questions in the chat yet, but if you want, we can run through my quick 2-slide closing slides and then open it up for Q&A.
Sure, that's it. Yeah, and if you have people have questions, they can bring them up, and we can just call on you, and you can raise your hand and you can ask the question. So I messed this up though by not sharing. So let me go back to sharing the screen so that I can show your. Show the last few slides. It's just my last slide. I just forgot we have other slides.
All good. Yeah, so just really quickly, we do have AIA learning units available for this lunch and learn here today. So if anybody either didn't include their AIA number or is having any issues there for any reason, feel free to reach out to me directly. I will be sending out follow-up emails either later today or tomorrow, which I will also be reporting AIA attendance at that time. But yeah, so slides, recording, and a feedback survey coming your way shortly, either today or tomorrow, as well as the handout Jay has been referencing throughout this afternoon with attached epiphanies. Couple quick upcoming courses. We're kind of rounding out our courses for the year. But this is actually a dated slide on the screen. Let's see, I can pull up our most recent. So yeah, just about 5 or 6 courses to finish us up for the year. Most of them are focused on the 2022 energy code changes. So like I mentioned, we have our regional forum in San Luis Obispo tomorrow at the Monday Club from 10 to 1 p.m. Focused on ensuring the IRA funding, the 2022 Energy Code, and California climate policies benefit the Tri-County region. That's tomorrow in SLO, in person. And then a couple webinars coming up. We have 2022 Energy Code preview for single family projects on Thursday the 10th. Next week, we have home assessments for decarbonization on the 15th, blower door basics and beyond on the 16th, and then another 2022 Energy Code preview for multifamily projects on the 17th. I believe there is a third part of that 2022 code update courses the beginning of December, but not listed here. So yeah, if anybody does have any questions, we can open it up for Q&A. I know it's been a quiet bunch so far.
We did get it up to the right one here. I apologize for not having it. I don't know. I didn't realize it was that it had slant animation when I put it in.
That's okay. But yeah, so listed here are the courses I just mentioned. You can find registration and any learning objectives, course description stuff on our website, 3cren.org. Yeah, so if there are any questions, feel free to unmute yourself. We do have a bit of time left, but if there are none, we can close up a little early.
This is the handout. It's the high performance. We won't read through it, but it shows the natural order of decarbonization, describes it. It shows the the way of presenting that it is there, and sets the deal for the importance of early planning, envelope first, and aspirational goals. So you will get that as a get that also in what you're what is coming to you there.
Yeah, and we've also started to include those handouts on our on-demand page for reference in the future.
So now you're all looking at my screen. No, I'm not still sharing. So we didn't.
Yeah, we're all looking at each other.
Yeah, I'm not sure I got it to the right way. Well, we're not looking. There's some people that are being quiet about or being private about it. Did any questions come up from Alfredo? Oh no, this is just a comment.
All right, well, we did include both of our contact information. So if anything does come up after the fact, feel free to follow up with either Jay, myself, or both of us. Happy to help either relay any questions or personally assist. So with that, we will finish up the Lunch and Learn for today. And I hope everybody is enjoying this rainy afternoon we're having on the Central Coast. Thank you all.